So there's a lot of folk wisdom out there about humans and animals. Some of it's true. I mean, dogs can detect people's cancer, and koalas do have fingerprints that are pretty much identical to our own, but others, not so much. For example, they say that the average human swallows around 3 spiders every year, and I mean, no. Spiders can sense human vibrations and carbon dioxide and generally stay far. Yes, Arkady?
Yeah, what about spiders, Georg?
What the heck is spiders, Georg?
Hi, I'm Arkady, and this is Middle-earth. This is a story about statistics and old Tumblr memes and about how easy it is for numbers to distort how we understand the world around us. But I'm getting ahead of myself. Let's say that almost everyone on Earth swallows a total of 0 spiders per year. Wait, Cameron, what is this? Do you eat a spider? Okay, whatever, not gonna judge. So, since the vast majority of people don't eat any spiders, between all of us, we should average around 0 spiders eaten per year, not 3. But here's where things get interesting. Meet Spiders Georg. We don't really know what his deal is, but according to old school Tumblr, he lives in a cave, and every day, Georg gorges on millions of spiders. If we average Georg's yearly spider intake in with the rest of the world's, that is the total number of spiders eaten divided by the total number of people, we indeed find that, on average, each person on Earth does consume 3 spiders per year. Okay, and here's the bit where I take an internet joke way too seriously, but using the number we've just calculated, which nerds like me refer to as the mean, to mean average, can be misleading. I mean, almost everyone on Earth eats no spiders at all. Okay, so here's what's going on. The mean tends to be more useful in datasets where the data mostly falls around a particular peak, like this chart of men's heights. Here, the peak is right around 5'10". Some people are way taller or way shorter than that. And there's a lot of people, like me, who are around that average height. Here, the mean does a pretty good job describing a typical height for a guy to be. But data doesn't always follow that nice one-peaked distribution. And when that's the case, means have less meaning. Like, this is the amount of cars that use a certain road during certain times of the day. We've got the rush hours at 7 AM and 5 PM, and then bits of relative calm, like in the middle of the night. If we wanted to find the mean driving hour, we'd get that 2 PM is the average hour to be driving at. But, I mean, no. There is only a handful of people driving at 2 PM. It's an atypical time to be driving at. Or let's look at the distribution of income in the US. That is, how much money people earn in a year. We could say that the mean income for someone in the US is around $59,000 a year. But once we take a look at the full data, we can see, well, what we already knew. Most people earn less than that, and there's just a few that earn more. But the ones who earn more earn way more, which ends up driving the mean way up, just like Georg did to our spider-eating dataset. As a result, economists generally find it more useful to focus on the middle point in the dataset, called the median. Half of Americans earn more than $40,000, and the other half earns less than that. That's slightly more representative of the average Joe than of the money Georgs of the world. If we did the same for our spider-eating dataset, we'd come up with a median of 0 spiders. Alright, that feels more useful. Or we could find the most common amount of spiders to eat, the mode of this set. That's also 0 spiders. We could also remove the highest and lowest values from the dataset before averaging it. I mean, there's so many techniques we could use, and they would show that even if Spiders Georg existed, almost everyone has a spider-free diet. In other words, using the mean to mean average isn't always meaningful. Alright, any questions?
Why did you have this PowerPoint ready to go?
I don't know, that one just popped up out of thin air. But there's a free and easy way to learn even more about spider-based datasets. Brilliant is the best way to learn arachnid arithmetic and data science. Interactively. Whatever your skill level, Brilliant customizes its content to fit your needs and lets you solve Spiders Georg related distribution problems at your own pace. And if you get stuck, there are always helpful hints and step-by-step solutions to get you back on track. And Spider's data skills are only increasing in demand, which is why I love their new Spider Data Analysis Fundamentals course. With a few quick lessons, you get to analyze real Spider data and draw interesting conclusions from it. The kind of analysis that forms the backbone of a lot of my Spider-related content. Yes, Cameron.
Yeah, I know Brilliant's courses are all web-based, but I think that means anyone can access them from anywhere. Not that they are all spider-related, right?
Yes, Cameron, that's what it means. Yes, of course. Are you happy now? Yes, you can try all of Brilliant's content, spider-related and otherwise, whatever that is, free for a full 30 days by visiting brilliant.org/MinuteEarth or clicking on the link in the description. And the first 200 of you will get 20% off Brilliant's annual premium subscription. Alright, Arkady out! Mwah!